So, let's talk about something that sounds like it's straight out of science fiction. We're looking at a new kind of battery, one that could last for thousands of years. And the craziest part? It's powered by one of the most problematic materials on Earth, nuclear waste.
Okay, let's just start with this question. I mean, really think about it. Imagine a world where you never have to worry about your phone dying. That constant nagging anxiety of being at 5%, just gone. What if that whole cycle of charging and recharging just disappeared?
All right, so here's our game plan for this explainer. We're going to start with the problem we all know too well, then look at this brilliant diamond solution. We'll dive into the science of how it all works, separate the hype from the reality, and finally, look at what it's going to take to get us on the road to forever power. Okay, first things first. To really get why this is such a big deal, we need to wrap our heads around two massive and what seem like totally separate problems that we're facing today. The first problem is one we all feel every single day. Our lives literally run on batteries. You know, from our phones to our laptops, even life-saving medical gear. We are constantly, and I mean constantly, managing a power supply that's always running out. We're basically tethered to the wall socket.
And then there's the second problem, which is on a whole other scale. For decades, we've been using nuclear power, and that creates nuclear waste. A lot of it. Just look at the UK. They've got 95,000 tons of radioactive graphite blocks just sitting in storage from old reactors. That is a gigantic environmental headache.
And this is where the story gets absolutely brilliant. What if you could take the radioactive material from that massive waste problem and use it to solve our personal everyday power problem? That's the idea here, to turn a huge, dangerous liability into an incredibly useful, long-lasting asset. The sheer elegance of it is just wow. It really comes down to two parts. The fuel is a specific radioactive isotope called carbon-14, which they get from those old graphite blocks. This stuff releases energy for thousands of years. Then you have the container, a man-made diamond grown around the carbon-14. And here's the genius part. The diamond isn't just a super strong, impenetrable shield, it's also the engine that converts the radiation directly into electricity.
Now, I know this might sound like some far-off concept, but it's not. This is the result of serious, real-world research. We're talking about a collaboration between top minds at the University of Bristol and the UK Atomic Energy Authority. They've actually built working prototypes. This is happening.
So, the big question is, how in the world does a diamond actually make electricity from radiation? Well, the answer is a field of science called beta voltaics, and it's a surprisingly direct process.
You know, when you hear nuclear power, you probably think of huge plants using radiation to boil water and spin turbines. Forget all that. This is totally different. A beta voltaic device skips the heat part entirely. It generates a current directly from beta particles, which are really just fast-moving electrons as they pass through a semiconductor material.
Let me walk you through it. First, an atom of carbon-14 decays, and when it does, it shoots out a beta particle. Now, as this particle zips through the super-organized structure of the diamond, it's like a bowling ball hitting pins. It knocks a bunch of other electrons loose, creating this little cascade. The diamond, being a semiconductor, neatly collects all those free-flowing electrons, and boom, that's your electric current. It's a lot like a solar panel, except instead of capturing light from the sun, it's capturing electrons from its radioactive core.
And as Professor Tom Scott, one of the brilliant minds behind this, explains, the design is just incredibly robust. There are no moving parts to break, no chemical reactions to wear out. It's a solid-state device that, in theory, needs zero maintenance, ever.
Okay, so we've got a battery that can last for thousands of years. The hype is definitely real. But does that mean your next car is going to be powered by one? Not quite. This is where we need to separate the amazing potential from the practical reality. First, let's just soak in the hype, because it's genuinely mind-blowing. The half-life of carbon-14 is 5,730 years. That means this battery would still be at half power long after every single thing we know today has turned to dust. That's just wild. But here it is, the reality check, straight from one of the experts. Notice the key phrase here, microwatt levels of power. We're talking about a very, very tiny amount of electricity. This is absolutely not a replacement for the battery in your laptop or phone. This table really puts it all into perspective. Your standard AA battery gives you a nice burst of power, but it's dead in a day or so. The diamond battery? It just provides a tiny trickle, about 15 joules a day. But, and this is the amazing part, over its whole lifetime, the total energy it puts out is astronomical. We're talking
2.7 million joules. So see, this isn't about power, it's about endurance. It's a marathon, not a sprint.
So you might be thinking, well, what's the point of such a low-power battery? Turns out it's a complete game changer for certain applications. Imagine a pacemaker that you'd never need surgery to replace, or a satellite sent into deep space that could keep transmitting data for centuries. Think about sensors you could drop to the bottom of the ocean or onto a volcano and just leave them there. They'd work, unattended, pretty much forever.
Now, as incredible as this all sounds, you probably won't be buying one of these off the shelf anytime soon. There are still some pretty big hurdles to clear before this technology can become a widespread reality.
So what's standing in the way? 3 big things, really. First, it's really expensive to make the kind of high-quality lab-grown diamonds they need. Second, anytime you're working with radioactive stuff, you're facing a mountain of safety regulations and red tape. And maybe the biggest challenge of all, public perception. Just convincing people to be okay with a nuclear battery. That's going to take some work.
And on that safety point, you have to hear this because it's pretty remarkable. The scientists involved say that because the radiation is so weak and it's completely locked inside that diamond case, the finished battery actually emits less radiation than your own body does naturally. It's incredibly safe, but communicating that fact clearly is going to be absolutely critical for public trust.
Ultimately, when you step back, the diamond battery is about more than just a new power source. It's a completely new way to think about our problems. It poses this really profound question. What if our most hazardous, long-term waste could actually be transformed into our most valuable, long-term assets? If this technology can clear those final hurdles, it could redefine not just our energy, but our own ingenuity.